and we exchange them, and we try to see what the effect is of doing that. Or does anybody have any better idea even? The panic password, of course. We can use the panic password as the private password, for example, the shredding password as the private password. And then we can do it even smarter. It's really a mess to take all this block there and exchange them and make sure you don't lose anything. So maybe you can do it much easier. Actually, we can just look at these ASCII characters. Remember the ASCII 1 and the ASCII 2? So, let's do some real hacking now. We take some very, very advanced tool. That's for the next demo. So we'll try to open, maybe it's still here. No, so we try to open on documents, private safe ECK. And then we use our hex editor eyes to find where we have the 3, and the 3 becomes a 2, and we try to find the 2, and the 2 becomes a 3, and we save the file. Oh, that's the demo effect. So let me, no. Let's see. Well, I'll do it again. I told you if 2 out of 3 demos work, we'll be happy, so. We don't launch anything, we just open the file. We take the 3, we make a 2, we take the 2, we make a 3, we save, yes. And then we do all the fancy launching, eCapsule private safe. It's going to have to look for everything. So let me just go on with the talk. So we find out that we can access the private data by using the panic password. Now, if you think about the utility, the reason there is a panic password, it should really not be possible to decrypt anything with a panic password, right? If it was well programmed, it would say, oh, panic password, let me just throw away the encryption key, erase all the data, wipe everything, and then create a new folder from scratch. And never ever touch the actual encryption key from any distance. So now I'm going to type the panic password. It's only 1 character. And if the demo works, we should have the private safe, the secrets. There you go. Thank you very much. So you would say this is really a strange software, right? I don't want to call any names. But so we called the company and we asked them, see, our customer doesn't want your software, it's no good. And they say, I'm sorry, I'm talking and doing. Yes, go away. So we called up the CEO of the company, and he said, well, my software works as advertised. If you look at the ad, it says you have 4 personal passwords. They are yours. Don't ever give them to anybody. If you give your panic password to the guy at the border, it's your problem, you shouldn't. I said it doesn't, it works as advertised, this is a personal password. And also, when I asked them, well, but you know, there should be other way of doing it, like if I did not put the private password into the system should not be able to decrypt the private information. Then they said, well, you know, but you are bad guys, you did some reverse engineering. There's no way, we can't protect against that. You know, as good as me, reverse engineering is just too strong. And then we had to talk about cryptography and make the difference between, you see, good cryptography is an intricate lock that you can not pick. And bad security is when you put the lock on the outside of the door, right? And everybody can remove it. So they should take a good lock and put it on the correct size of their door. Right. So the last one, this is a very old software which doesn't exist anymore, but we had this customer who says, I still have this old container with information in it from a software, and we'd be happy if we could brute force that to get access to that software. Is there anything that could be done with it? And I forgot to take my requisite for this presentation. It's the small yellow booklet from Data Becker. Maybe you remember those with the instructions. And on the second page or so, it says, "Gute Software muss nicht teuer sein." So this, I got it for €5 on eBay, so it was really cheap, but I think it really was cheap also in the way it was built. So what does this software do? Oh, let me just start it and boot up the debugger again. So I have my private safe here, which I could want to open. And then, those were the days, right? You don't see many of these anymore. So let me just attach that again so that we can talk. Okay, so let it do its magic, and we go back to here. So what it does, again, there's a file system, and there's a control block, but in this case, the control block is at the beginning of the file system. So it's one huge file with the control block and the file system in it. The whole file system is encrypted with Blowfish, which is a very good encryption algorithm again, so it's a very good lock, very complicated. And they use CBC mode for the encryption, which is also a good mode. And the initialization vector they use for CBC is the same all the time. It's a constant. That's not very nice. So it's 0, 1, 2, 3, 4, 5, A, B, C, D, E, F. That's the initialization vector. They took some crypto textbooks, I guess, about encryption, and they saw this example, and I thought, that's a nice example, I can remember that. And then they used that, right? Then what we also saw is that when it starts decrypting the file system block by block, the first two integers of the block are some low numbers. It's probably the count of the block or whatever. Again, we don't understand everything, but it's enough for us to understand the bug. So there's a small number, there's 3 bytes of 0 and one value between 0 and 10 or something like this. So from this we can know whether we have a right key and we are succeeding in decrypting the block or not, right? So knowing all this information, let us see if we could do some brute force, try all the passwords and see if we get lots of 0 bits in the blocks in the beginning, but this would be very slow because Blowfish was designed to be very, very slow on the key schedule on purpose so that brute forcing would be very slow. So we loaded the debugger and tried to see how this thing works in here. So I let it run and I typed the password, which is test1234. So we'll see if we see it appear somewhere in the program. It's a little slow, but it should appear. There we go. Öffnen. And there I have a breakpoint at some funny routine. So we see this routine is being called. It has a parameter which is the password here, test1234. And for those of you who can read that, for those of you who can't read that, I'm just going to explain to you. This is a loop. It's going to loop over all the characters of the password. So this is the first part. It subtracts 1 to the length of the password, and if it's 0, it stops. And if it's not, it goes on. So 8 times it's going to go through this loop. And what it does, it shifts left there's a variable at EBP-4, which is going to be shift left at every loop. And then somewhere later, there's going to be an XOR with the current byte of the password with this shifted other byte. And then we go for the next password, we shift again, and we XOR with the next character. So I'm not going to do all of that by hand, but you get the idea. So you see now it only says est1234. It takes every character one after the other, and it creates this shifted XOR of all those characters. I think that's enough. I'll show you the rest on the slides. Let me just let it run, so maybe we can look at it later. So what is that? This is somehow a checksum. This programmer thought, well, what happens if the user types in a wrong password? And then I decrypt my whole file system with the wrong key, and then I have a file system which just means nothing, with pointers which go all the way, and so this is really bad. I have to do all this error checking afterwards. I don't want to do that. I want to be sure the password is correct before I ever try to decrypt the file system. So I'll make this small checksum, and I'll hide it somewhere in the control block so I know if the password is the correct password or not. And this is exactly what happened in this routine. So